Yes, this C sub A is the coefficient, no? This can be found in the table, and I is the importance factor. R, this is the value in the table also, which is for moment resisting frame, concrete moment resisting frame, special moment resisting frame, which is equal to 8.5, no? And T, this is the period of, for example, earthquake or pila ka seconds siya mo last. And W, this is the weight of the structure or building. So this should not exceed this formula. This is sub A. This can be found also in the table in the ECP 2015. And total bases and shear shall not be less than the following. This one also. And for seismic zone 4, the total base shear shall not be less than this formula. So we have this table which can be used in this design base shear, no, which is the V. So we have the different types of occupancy category of your structure if it belongs to essential facilities. So this is the condition, no? Occupancies having surgery and emergency treatment areas, so fire and police stations, garage and shelters for emergency vehicles and emergency aircraft, structures and shelters in emergency preparedness centers, aviation control towers, structures and equipment in communication centers and other facilities required for emergency response, facilities for standby power generating equipment for category 1 structures, tanks or other structures containing housing or supporting water or other fire suppression material or equipment required for the protection of category 1, 2, or 3, 4, and 5 structures, public school, buildings, hospitals, designated evacuation centers, power and communication transmission lines. While these hazardous facilities, if imong purpose imong building is for hazardous facilities, so this category 2, no, imong i-base, imong design. So occupancies and structures, housing or supporting toxic or explosive chemical or substances, non-building structures storing, supporting or containing quantities of toxic or explosive substances. Then for special occupancy structures, so dapat fall ka ani nga categories. Your building with an assembly room with an occupant capacity of 1,000 or more. Educational buildings such as museums, libraries, auditorium with capacity of 300 or more occupants. Buildings used for college or adult education with a capacity of 500 or more occupants. Institutional buildings with 50 or more incapacitated patients but not included in category 1. Mental hospitals, sanitariums, jails, prisons, or other buildings where personal liberties of inmates are similarly restrained, churches, mosques, and other religion facilities, all structures with an occupancy of 5,000 or more persons, structures and equipment in power generating stations and other public utility facilities not included in category 1 or category 2 and required for continued operation. Then for standard occupancy, all structures housing occupancies or having function not listed in category 1, 2, or 3, and 5. And these miscellaneous structures, private garage, carports, shed, and fences over 1.5 meter high. No? So from this, we have this corresponding seismic importance factors from your occupancy category kung asa siya nabilong, then you have this corresponding seismic importance factor I, no? So we'll use this I. This actually importance factor from NECP 2015, this one, and this one is from 2010. So difference of which is that not change ang ihang hazardous facilities into 1.25 seismic importance factor in 2015, ECP 2015. So we have this soil profile types for different soil profile type, no? We have this notation and the corresponding iyahang description, what is that kind of soil, and we have this average soil properties for top 30 meter of top 30 meter, no, from the ground, no, of soil profile. So this is the shear wave velocity, no, corresponding shear wave velocity, standard penetration test of N blows per 300 millimeter, no, and undrained shear strength SU. Now this is the iyahang properties or characteristics, no, for different soil profile type. So kung sa inyong soil profile, usually kung mag-design, no, sa ako ang na-experience is mag-design ko actually maiwit yun na ang soil test. So before ta mag-design of foundation, we have to know what kind of soil, no, naaana nga lugar. So that is why I usually assume, no, nga ang soil is steep soil profile. Steep soil profile that has this 180 to 360 shear wave velocity, no, that is S sub D, no. I usually kuan siya assume nga S sub D ang soil profile, especially nga wala pa ko kabalo sa soil test or ang bearing test sa soil. We have also a table for the seismic source types, no, table from NECP 2015 and table from NECP 2010. As you can see, so naagihapoy changes, no, of for example, seismic source type A. This is seismic source description: faults that are capable of producing large magnitude events that have a high rate of seismic activity. So the maximum moment magnitude that is between this 7.0 to 8.4, while in NECP 2010, M or the magnitude is greater than or equal to 7.0, no. These are the changes or the change. For seismic source type B, all faults other than types A and C. So magnitude is between these values. And C, faults that are not capable of producing large magnitude earthquake and that have a relatively low rate of seismic activity. So the magnitude is less than 6.5. So we have this A, which is 7.0 to 8.4, no. Because I think, no, sa Philippines, history sa Philippines, wala pa magnitude no nga greater than 8.4, perhaps, no, wala pa. So that is why in here the provision give this values, no, for seismic source type A producing large magnitude events. And yeah, we have these factors, no, for near source factors. So in 2010, wala kay makita nga factor for those structures nga less than or equal to 2 kilometers from the source of seismic or we say fault line, no. In 2015 na siya. No, these are the changes or this is the change, no. And this one also, no, the near source factor in N sub A, seismic source type, this ABC is this refers to this one, seismic source type ABC. And yes, there is we could use this factor N sub A and N sub B later in the computation of our base shear, no. And this one also seismic coefficients, C sub A and C sub V, no. What are the changes now from NECP 2010 to NECP 2015? I think almost all, no? All factors or coefficients are the same naman siya. So, parihara siya, no? Parihara sa 1,000. 2015 is the same with 2010. So, we have seismic zone 0.2 and 0.4. So, later, asa nidapit ang 0.2 and 0.4 nga seismic zone. And we have the soil profile type. So, itong soil profile type is katong previous nga slides ganina, which is this one, no? Soil profile type. Then, they have this corresponding factor or coefficient which will be used, no, to determine our base shear, no, later in the computation of our seismic load, no. So this one, and this is, I think, is this continuation or the same lamination? Okay, the same slide, no, the same slide. So we'll move on to these response modification factors or the overstrength factor. So R actually is the response modification factor. So common factor that we'll be using in the design is this 8.5, no? 8.5, which is the special reinforced concrete moment frames, no? In our computation, or can be incorporated in the STAAD also, no, for seismic. And we have the seismic map of the Philippines. The Philippines is divided into two seismic zones. So this is what I mentioned earlier. What are these two zones, no? Katong ganina sa table, these two zones. This one, no? 0.2 and 0.4. This one, seismic zone. So we will recognize, or we will see where is the seismic zone 2 and seismic zone 4, no? Seismic zone 2 is the islands of Palawan, Tawi-Tawi, and Sulu, and seismic zone 4 is the area of the rest of the Philippine islands, no? This one, seismic zone 4 and 2. And another map of the Philippines for distribution of active faults and trenches from PHIVOX, no? So try to search also from the internet the latest kuan kanang active faults, no, in the Philippines. So this is dili kay siya maklaro, pero we'll try to klaro. But anyway, move on because naigapanawag.